Welcome to Grade 5 Math, Chapter 2.3, Multiplying by Two-Digit Numbers. The objectives of this lesson are to multiply a 2, 3, or 4-digit number by a 2-digit number. Let's begin. We'll begin this lesson by revisiting the idea of multiplying a 2-digit number by tens. We learned how to do this in 2.2. Let's multiply 12 times 30. The method we learned in the last portion of the chapter was to break the 30 apart and to think of this problem as a 12 times 3 tens. So 12 times 3 times 10, which would give us our answer of 12 times 3 equals 36 times 10. And then if we follow our rule of 10, we simply add our 0 to the end of the number, giving us an answer of 360. I want to show you another technique or another method for completing this problem next. Method 2 that I'm about to show you now is often called standard long-form multiplication. This is the way your parents and I probably learned to do it when we were in elementary school. In long-form multiplication, you write your problem vertically. So we'll place our 12 here and our 30 here, with our multiplication sign here and our equal sign here. It's important in these problems to ensure that your ones place and your tens place are aligned. Our first step in this multiplication problem is to multiply the 12 by 0, which is in our ones place. So 0 times 12 is 0. So we'll place a 0 here as a placeholder. Now we're going to multiply 12 by 3 in the tens column, or 12 by 30. So we will take 3 times 2 in the ones place to get an answer of 6, and 3 times 1 in the tens place to get an answer of 3, giving us a final answer of 360. Let's try another problem like this. What is the product of 60 times 20? Let's solve this using method 1. In method 1, we'll split the problem to 60 times 2 times 10. So we'll look at our 20 as 2 tens instead of 20. Our answer here will be 60 times 2 is 120 times 10. And following our rule of 10, we simply add our 0 to the end, and our answer becomes 1,200. Let's try method 2. In method 2, we'll line up our problem vertically, 60 times 20. Once again, we'll multiply our top digit by the ones place of our bottom digit, so 0 times 60 gives us an answer of 0. Now we multiply our top digit by the tens digit on our lower number, so 60 times 2. 2 times 0 gives us a 0 in the tens column. 2 times 6 is 12. And here is our answer of 1,200. Now let's up the difficulty a bit by using two two-digit numbers. In this problem, we're going to multiply a two-digit number, 63, by another two-digit number, 28. All right, no ability to break this one into sets of 10. So we're only going to be able to use the standard long-form multiplication method. So I need to rewrite this problem, don't I? Here we go, this looks better. We'll set it up vertically. So let me walk you through this step by step. First, we're going to multiply 63 by 8 ones. And the process works like this. I take 8 times 3, and the answer to 8 times 3 is 24. So I'm going to put the 4 in the ones place, and I'm going to carry the 2 up here into the tens column, so I don't forget about it. We're not going to ignore it. We need it in a moment. Now I take 8 times 6 in the tens place. 8 times 6 is 48. But we also add this 2 that we carried to get an answer of 50. So I'll put 0 in the tens column and 50 in the hundreds column. Now we move on to the tens. The first thing we need to do is put a 0 in the ones column to show that we're working with 20, not 2. So 2 times 3 multiplying our 2 times our 3 and 63 in the ones place gives us 6. Now we take 2 times the 6 in the tens place, and we get an answer of 12, which will be placed in the thousands and the hundreds column. Now we finish this problem by adding these two numbers together to get our final answer. 4 plus 0 is 4, 0 plus 6 is 6, 5 plus 2 is 7, and 0 plus 1 is 1. So our final answer is 1,764. The final step in a problem like this is to estimate to check your answer. So let's do a quick estimation to see if our answer is reasonable. Well, let's see. We could multiply 60 times 30, rounding both numbers, correct? And 6 times 3 is what, guys? It's 18, right? We have 2 zeros to add back on. So our estimated answer is 1,800. So is our answer of 1,764 reasonable? Sure is. You can be pretty confident if they're that close that your answer is reasonable and you've done your multiplication correctly. Let's try another problem. Now let's multiply 97 times 53. I'll walk you through this step by step once again. So our first step is to multiply the 97, our top number, by the 3, the bottom number's ones place. So let's take 3 times 7, which gives us an answer of 21. We need to carry that 2 into the tens place. 3 times 9 is 27. We add this 2 to give us an answer of 29. The 9 going in our tens place and the 2 falling into the hundreds place. Now we move on to multiplying by 50, the 5 in our tens place. So we have to put a 0 here as a placeholder to remember that we're working from the tens place. 5 times 7 is 35. Once again, we need to carry that 3. I'm going to cross out the 2 so I don't get confused. And now I'll take 9 times 5 to get 45. I need to add that 3, we can't forget about it, and that gives me an answer of 48. The 8 goes in the hundreds place and the 4 in the thousands place. Now I finish up this problem by adding these 2 columns together, or these 4 columns together to get our final answer. 1 plus 0 is 1, 9 plus 5 is 14, put down the 4, carry the 1, 1 plus 2 is 3, plus 8 is 11, place down our 1, carry the 1 from our tens place, and 1 plus 4 is 5. So our final answer is 5,141. Recall our last step is to check to see if our answer is reasonable, and we'll do that by estimating by rounding. So 97 is close to 100, 53 is close to 50, so we'll put a 0 here. 5 times 0 is 0, 5 times 0 is 0, 5 times 1 is 5, and our estimated answer is 5,000. At only 141 apart, I'm going to go with this being a reasonable answer based on our estimate. I am confident that our answer of 5,141 is correct. Try these 2-digit multiplication problems on your own. Please record your answers in your notebook. You may use either method 1 or method 2 if you're multiplying by a multiple of tens. On the 2-digit multiplication problems that don't include a multiple of 10, you'll need to use method 2. Please show your work so I can understand your math thinking. And please don't forget, estimate to check if your answers are reasonable at the very end of your process. Press pause. I'll be here waiting with 3-digit numbers when you come back. Now that we're comfortable with 2-digit numbers, let's move on to 3-digit numbers. We're going to learn to multiply a 3-digit number by tens. This process is very similar to the process you use to multiply a 2-digit number by 10, so I know you're going to pick this up quickly. So let's begin by multiplying 520 by 30. Method 1, as learned before, allows us to split 30 into 3 tens, writing our problem like this. Now we multiply 520 times 3. 3 times 0 is 0, 3 times 2 is 6, 3 times 5 is 15. So our answer is 1,560 times 10. Following rule of 10, we simply add our 0 at the end, giving us a final answer of 15,600. All right, there's method 1. Now let's look at method 2. In method 2, we use standard long form multiplication. So we're going to stack our digits, making sure our tens and ones places align. Please notice that I'm putting the larger digit, the digit with the higher value, on the top. We have our extra place value is going on the top here. So now we solve as we did before. Our 0 times our 520, we know, gives us a value of 0. So we're just going to place a 0 here to hold our place. Now we'll take 30 times 520. 3 times 0 is 0. 3 times 2 is 6. 3 times 5 is 15. We add our comma, and our final answer is 15,600. All right, Smarties, now we're going to learn to multiply a 3-digit number by a 2-digit number. I know you can do this. So let's multiply 623 times 32. Once again, we have to use the long form method. Method 1 won't work because we're not able to split either of these numbers into a number times 10. We'll follow the exact same steps as we followed for 2-digit times 2-digit numbers. So let's begin by multiplying 623 times 2. So we'll take 2 times 3 in the ones place and place a 6 in the ones place, as that's our answer. We take 2 times the 2 in the tens place, or 2 times 20, giving us an answer of 4 or 40 that goes in the tens place. Then we take 2 times 6 to get an answer of 12, which will actually be 1,200, and we'll take up the thousands and hundreds column. Now we put in a placeholder 0, as we're going to be multiplying by 30, and we take our 30 times 623. 3 times 3 is 9, in this case 90, because it's 30 times 3. 3 times 2 is 6, or in this case 600, because it's really 30 times 20. And 3 times 6 is 18, or once again in this place, 1,000 or 18,000, because it's 30 times 600. Now we add. 6 plus 0 is 6. 4 plus 9 is 13. Write the 3, carry the 1. 1 plus 2 is 3, plus 6 is 9. 1 plus 8 is 9, and our 1 comes down on its own. So our final answer is 19,936. Now let's use estimation to check for how reasonable our answer might be. We'll round 623 to 600 and 32 to 30, giving us an answer of, let's see, 0 times 600 is 0. 3 times 0 is 0. 3 times 0 is 0. 3 times 6 is 18, giving us a rounded answer of 18,000. Well, what do you think? Is that close enough to feel reasonable? I think so. I would say our answer is reasonable, and we can be fairly confident that we've done our multiplication correctly in this problem. Let's try another. Our next problem is 514 times 72. Okay, let's begin. First, we take the 2 in our 72 and multiply it by 514. 2 times 4 is 8. 2 times 1, or in this case you can think of it as a 10, is 2, or 20. 2 times 5, or 500, is 10, giving us an answer of 1,000. Now, we put in a 0 as our placeholder because we're going to be multiplying 514 by 70. We take that 7 times 4, giving us an answer of 28. Have to carry our 2, don't want to forget about that 2. 7 times 1 is 7, plus 2 is 9. We'll put that in our hundreds column. And 7 times 5 is 35, which goes in our 10,000s and thousands place. Now, let's add it all together. 8 plus 0 is 8. 2 plus 8 is 10, so we put down the 0 and carry the 1. 1 plus 0 is 1, plus 9 is 10. Once again, put down the 0, carry the 1. 1 plus 1 is 2, plus 5 is 7. And 3 comes down all on its own, giving us a final answer of 37,008. Final step, check for reasonability. So let's round 514 to 500 and 72 to 70. 0 times 500 is 0. 7 times 0 is 0. 7 times 0 is 0. 7 times 5 is 35,000. So is our answer reasonable? Well, we're within about 2,000. So when considering we're looking at a scale of 35,000 or 37,000, I'd call it pretty close. So I would say I'm confident that we've done our multiplication correctly, and 37,008 is our correct answer. Try these 2 by 3-digit multiplication problems on your own. Some of these have a multiple of 10, and you're welcome to use either method 1 or method 2, as long as you show me your work so that I understand your math thinking. The problems that do not include a factor that is a multiple of 10, you'll have to use method 2 alone. But still show me your work so I can understand the way you're thinking about the problems and help you if I can see where you're making any errors. Please record these answers in your notebook, and I'll be back in just a moment to finish out this chapter with you with our final 2 slides. Let's move on to our final 2 ideas in the chapter. We're going to learn to multiply a 4-digit number by tens, and then to multiply a 4-digit number by a 2-digit number. These ideas are exactly the same as what we've worked with 2-digit and 3-digit numbers, so you should definitely be seeing the patterns by now, and I'm confident you'll get this quickly. So let's begin with our first sample problem. We're going to multiply 7,360 by 20. You may use either method 1 or method 2 to solve this problem. In method 1, we'll take 7,360 times 2 times 10, because once again, we're breaking our 20 into 2 sets of 10. 7,360 times 2 would be, let's see, I'm going to take 2 times 0 to get 0, 2 times 6 to get 12, carry my 1, 2 times 3 to get 6 plus 1 is 7, and 2 times 7 to get 14. Okay. So 7,360 times 2 is 14,720. I'm going to multiply that by 10. Following my rule of 10, I just put that 0 on the end, right? So it becomes 147,200. There's method 1. Now let me show you method 2. In method 2, we'll use the long form multiplication, which means we're going to stack up our problem like this. 7,360 times 20. Notice once again that I put the larger number on the top, and I continue to line up my ones in my tens place. So our first step is to multiply 7,360 by the 0 in our ones column, which just gives us 0. So we're just going to put a 0 there as a placeholder. Now we'll take 2, or 20, times 7,360. So 2 times 0 is 2. 2 times 6 is 12, so I'll put down my 2 and carry my 1. 2 times 3 is 6, plus 1 is 7. And 2 times 7 is 14. So 147,200. All right, Rockstar multipliers. Now we're going to move on to multiplying a 4-digit number by a 2-digit number. This works exactly the same way as what we've done with 2-digit and 3-digit numbers. It's just a bigger number to work with. So let's begin with our first sample problem, which is 5,362 times 76. Do notice that once again, as always, our larger number goes on top, and we make sure that all of our places are lined up so that our ones are lined up with ones and our tens lined up with tens. If we had hundreds here or thousands here, we need to ensure that they were lined up properly as well. So let's move on and go through the steps of this problem. Our first step is to multiply 5,362 times 6. 6 times 2 is 12. Our 2 goes in the ones column. We need to carry our 1 over to the tens column. 6 times 6 is 36, plus 1 is 37. Our 7 will go in the tens column. We carry our 3 into the hundreds column. We don't want to forget about it. We need that value. 6 times 3 is 18, plus 3 is 21. So we'll place the 1 in the hundreds column, and we'll carry the 2 into the thousands column. Finally, 6 times 5 is 30, plus 2 is 32. So our 2 will go in the thousands place, and our 3 in the 10,000 place as a value of 30,000. All right, now let's put our 0 here as our placeholder so that we can remember we're really multiplying 5,362 times 70. We're just going to treat it like a 7 because it makes the job easier. So 7 times 2 is 14. We'll put our 4 in our tens column, carry our 1. Make sure you X out the old numbers so you don't get confused. Carry our 1. 6 times 7 is 42, plus 1 is 43. So here, 3 goes in our hundreds column. Carry that 4. 7 times 3 is 21, plus 4 is 25. So the 5 goes in the thousands column. Don't forget to carry that 2. And 7 times 5 is 35, plus 2 is 37. So our 7 goes in the 10,000s, and our 3 in the 100,000s column. Now we add these two numbers together. 2 plus 0 is 2. 7 plus 4 is 11. Put down your 1, carry your 10. 1 plus 1 is 2, plus 3 is 5. 2 plus 5 is 7. 3 plus 7 is 10. Put down your 0, carry your 1. 1 plus 3 is 4, giving us a final answer of 407,512. Don't forget our last step, which is to ensure that we are checking to see if our answer is reasonable by using estimation. So we would round 5,362 to 5,000, which we're going to multiply by 80 because we'll round 76 to 80. So 0 times 5,000, we'll have a 0 in our ones column. 8 times 0 is 0. 8 times 0 is 0. 8 times 0 is another 0. And 8 times 5 is 40, giving us an estimated answer of 400,000. 400,000 and 407,512 are close enough together that I feel confident we've done our multiplication correctly and that 407,512 is our correct answer. And here are your last 6 guided practice problems for this chapter. Please show your work so I can understand your math thinking. And don't forget to estimate to check for reasonable answers. I'll see you tomorrow to practice even more multiplication. Have a great night, and I look forward to seeing your work tomorrow.